Hi and welcome to Unit 1, Topic 3, Video 19. And in this video, we're going to go through and do some examples of the tangent theorems. So Theorem 5, 6 and 7, or Tangent Theorem 1, 2, 3, or whatever you're calling them. So let's have a look and see how far we get. Example 6, calculate the value of x. So again, I'm going to start by mapping this out. I'm going to start with x. What do I know about x? Well, I know that this is 90 degrees because it's inside a semicircle. Therefore, I know that this is 90 minus x. Can I use that value? Well, maybe, but I also know that this is x, alternate segment theorem, because I've got a chord there. And so I can use that x and that x to be equal, and that x and this angle add to give 90, which doesn't help me a great deal. But that 100 degrees is probably going to be used. This is 80 degrees. Therefore, 90 minus x equals 80 degrees, and I can work out the value of x. So that's what I'm going to go through. You see, playing around with it takes a little bit of time, but I'm building that up. So let's do the proof now. I'm going to call this T. I'll call this A and B. I've got O there, and probably help if I had this C labelled, and I'll call that S there just in case. So I've got some labels. I'm going to start by saying angle OCT equals 80 degrees, and this is just angles on a straight line. And then I'm going to go, I know that angle BAC equals 90. This is angle in a semicircle. And therefore, angle BTA is equal to 90 minus x. So I know that to be true. This is angle sum, angle OTS equals 90 degrees. This is angle between chord and tangent. So I've got this right angle here. I've got 90 minus x here. I could prove that x with alternate segment theorem, but I'm going to use this information to say that therefore angle SOT equals 70. This is angle sum in a triangle. And then if I consider, I'm wondering if there was maybe a shorter way now, but if I consider triangle in triangle OCT, I've got angle SOT equals 70, and I've got angle OCT equals 80, and so therefore angle OTC equals 50, which is angle sum of a triangle, 180 minus 70 minus 80, and by 50 I mean 30, of course. And therefore 90 minus x equals 30, and x must equal 60. So there's my rearrangement solve, calculate x. That took a bit longer than I thought, and I'm pretty sure there's a shorter way of doing it, but I can't see it immediately. So there's a challenge for you. Have a play with that and see if you can find a quicker, more obvious way of doing it. And that's example 6. Let's have a look at example 7. In example 7, I want to develop an alternate proof to the alternate angle theorem, or the alternate segment theorem, prompted by the diagram given. So here's the alternate segment theorem, that this angle is equal to alpha. So here's my alternate proof. I'm going to say angle BOA is equal to 2 alpha. And I'm also going to say that OA is equal to OB is equal to a radius. Now this one here is circle theorem 1, which is angle at center equals 2 times angle at circumference. And this their radiuses because they're just given by the circle. And so therefore angle OAB plus angle OAB equals angle OBA, and angle OAB plus angle OBA plus angle BOA equals 180. Angle sum of a triangle, and this one here is due to isosceles triangles. And so now I've got that information. I know BOA is equal to 2 alpha, and I know that OAB plus OBA, they're equal, and I want to deal with this angle here, so OBA, so I call this 2 times angle OBA plus 2 alpha equals 180, and that means that 2 times angle OBA equals 180 minus 2 alpha, which means that angle OBA equals 90 minus alpha. Now we know that, and so running out of space again, angle ABU, actually no, angle OBU, I need to make this statement first, is equal to 90, because this is an angle between radius and tangent. And so OBU equals 90, which means that I'm going to make the statement now that angle OBA plus angle ABU is equal to 90, because that's OBU, split up into 2 parts, which means that 90 minus alpha plus angle ABU equals 90, which means that angle ABU equals alpha, and that's equal to angle BPA, and this is the alternate, I'll swap that around for some reason, alternate segment theorem. Okay, so there we have the alternate segment theorem defined and done using the information that we have and prompted by that diagram. So that's example 7.